Hi, I am T. Kavita, Assistant Professor, Department of Mathematics. Today's topic is inverse function. Introduction to inverse function. A function has an inverse if it is one-to-one and onto, that is bijective. The inverse function reverses the mapping of the original function. An inverse function is a mathematical function that reverses the operations of another function. If an original function f takes an input x and produces an output y, the inverse function denoted as f inverse takes y and returns x. Definition: if f is mapping from a function f is mapping from a to b is bijective, then the inverse function f inverse is mapping from b to a is defined as f of a is equal to b. That implies f inverse of b is equal to a. Here we give the picture function f of x, its inverse f inverse of x, domain 2, 4, 11, the images are 9, 5, 6. Here the inverse function f inverse of x, the domain is 9, 5, 6, the images are 2, 4, 11. For two functions to be inverse, their operations must cancel each other out completely, resulting in the original input f of f inverse of x is equal to x and f inverse of f of x is equal to x. This is the fundamental property. Every inverse function satisfies f inverse of x is equal to x and f inverse of f of x equal to x. Here the example, f of x is equal to 2x plus 3. To find its inverse, replace f of x with y, swap x and y, solve for y. Therefore, we take f of x is equal to y is equal to x plus 3. Now, we can find x is equal to y plus 3, y equal to x minus 3 by 2. Therefore, f inverse of x is equal to x minus 3 by 2. To find the inverse of a function f of x algebraically, we can use 4 simple steps. That is, replace f of x with y. That means write the equation as y is equal to expression. Swap x and y. Interchange all instances of x and y to reverse the mapping. Next, to solve for y, use a standard algebra to isolate the new y, rewrite as f inverse of x. Replace the isolated y with the inverse notation. This is the basic steps to find inverse function. Here the table values, example 2, x is equal to 1, 2, 3, f of x is equal to x plus 1. We add 2, 3, 4, inverse table, swap x and f of x. Here y is equal to 2, 3, 4. Then f inverse of y is equal to 1, 2, 3. This is the graphical interpretation. A function and its inverse or mirror images across the line y is equal to x. Reflection property helps identify inverse visually. This is the horizontal line test. A function is invertible if and only if it is one and one. The horizontal line test. Here the graph is given here. Non-invertible function example. Let f of x equal to x square for all real numbers. It is not 1, 1. So inverse does not exist for all results. But restricting the domain to x greater than or equal to 0 makes it inverse. Failing the horizontal line test for the function f of x is equal to x square. Here the horizontal line test 1 to 1 is satisfied or not 1 to 1. Here the steps to find inverse function: write y is equal to f of x, interchange x and y, solve for y, replace y with f inverse of x, verifying using f inverse of x and f inverse of f of x is equal to x. This is the key properties for domain and range swap. The domain, all possible x values of the original function, becomes the range, that is all possible y values of the inverse and vice versa. Graph symmetry: the graph of an inverse function is a perfect reflection of the original function's graph across the diagonal line y is equal to x. 1-to-1 requirement: an inverse function only exists if the original function is 1-to-1. This means every distinct input gets a distinct output. It must pass the horizontal line test. Here the summary is: inverse function reverses the original mapping. exists only for bijective functions, represents as f inverse of x. Graphically, it is reflection over y is equal to x. Horizontal line test determines invertibility. Thank you.